statistics and data analysis, many people are interested to use the R software as a tool to plot and design their codes. First of all, what is R? R is just simply a language designed to package all the codes needed for visualization. But the R Studio is an environment that consists all the codes needed to make that graph happening. Assalamu alaikum, yattikum al-afiyah. My name is Yusuf Jafar. Inshallah, we will work. I personally will introduce and will teach this course with my brother Anwar. We inshallah will make great efforts to teach this course. First of all, we have the first screen is the source editor, and this is basically will consist the place or the where the scripts will be written to give an order to the software. Second of all, we have the console. Here is just how the program reacts to our commands. Third of all, we have the environment and history. Here will all the sets and data will be stored. And finally, we have the packages. All the packages and files will be visualized here in this screen. There are types for writing scripts. First of all, if in case we have a hash, this is just a comment. So the R software will not react to this comment. Otherwise, if we type an X as a function and we decide that X has a value of some certain number like 15 or other numbers, we basically can plug the X, then we will type Alt and the negative sign, then the number, and we run it. After that, it will just simply store the X as a function that has a value 15, and we can do that as well as for other variables like Y and Z, etc. Then we can make an advanced variables like Y plus Z. Additionally, sometimes you will have some confusion and we don't know, for example, what is the mean? So we want to ask the program a question. So if the question about a basic idea like mean and this stuff, so we can run it by just the first typing the quotation mark, then mean. Secondly, we can type help, then mean inside the parentheses. So here is just a quick how the R Studio react, and it gives a wonderful result and about the mean, as you can see. Or we can type just help and mean, it will give exact same thing. But in case if we have like an concepts like regression, for example, we have to use double integration sign. Sorry, I think quotation mark, or so we just type this twice and type the concept. Some other variables, like in case of T, we can't set the T as a variable, and it's gonna be not accurate, and if we run the T, it will give true, or even I and Q. So we have to be careful about some variables like T I, Q. These all cannot be used or set as a variables of numbers, or we have to be careful. So we rather use X, Y, and Z, but we cannot use TIQ for variables. And then we can also do simple math, like setting, for example, A as variable number 5, and we can do the multiplication. Also, we have the sequence. For example, if we are randomly setting values from 1 to 15 and there is the space between them 3, so if we run this command, we have 1, 4, 7, 10, 13. So the 3 space between them, and it's just picking a random value between 1 and 15. Also, the other method to do it is just sequence 1 to 6, and if we run it, it will give the same thing. Also, if you have to set multiple variables, so we can make them in a concatenation sign, like first of all nums, then assign it C3579. But this is itself, it cannot be run. We have to type also nums, then run. It will give these values that inside the set. Also, we can, since we have many other options, like for example, we have also character, logical, integer, numerical. This is the data types. We can just set a numerical, which is 3 to 9, or logical, like false, true, or character, we can write type names. So if we run this to command, it will give us the same thing. So let's move forward, and there is more interesting topics, and as we go forward, I have been using this command. It's called SumDice, and basically in our function, that this is just that a function that sums or add the rolls of an n for dices. We usually use some dices for card or whatever, so you guys know what dices is. So first of all, to make this operation, we simply start with SumDice, set it as a function n, and we need to open the parentheses. Why we need this open braces? Sorry, because all orders, all these commands that inside the braces will be activated as inside the function to activate the whole as one. So we have SumDice, we set the function n and the variable rolls, then we set the sample from 1 sequence 6, then the size n, we set so we simply defining what our rolls. So we have 1 to 6, the size n, then we activate the replace truth. It's just saying this. It means that, for example, if it's picking number from 1 to 3 or 5 to 6, so it can go forward and backward at the same time. So it can pick 3, then 2, then 2 or 3. Like this is how it's not only picking forward like 1 to 6, 1, 2, 3, 4. No, it can go forward and backward, 1 to 3 or 3 to 1. Then we have to we have to also write a command. This is to give an answer to this 27 code. Return. It's just simply to provide an answer to our operation. This code, whole code, can be activated, but the problem is we have to extend it and really pick what's the number we want. So if, for example, if we roll a dice for what's number, like if we roll it 100 times, so we have to insert or type some dice 100 and then run all this from 26 to 30, and now our codes it's activated, as you can see, and it's simply stating that if I'm having the dice, I'm rolling a dice for 100 times, what is our resulted value? So it will give 342. Now, brother, go ahead.
Okay, so let's start with the R and R Studio. Okay, so this programming language has two parts. Okay, one is R and one is R Studio. Okay, this R is language actually. Okay, language designed for statistics, data analysis, and visualization purposes. Okay, means plotting. Okay, so it can also plot, it can graph it, it can have box plots, etc, etc. Okay, so it can also visualize your data. Okay, the other part is R Studio. Okay, so this is an environment. Okay, environment which on back end is supported by R. Okay, so this is an environment which uses R in its background. Okay, and it makes the use of R easy. Okay, so if in simple terms, okay, R is the engine, okay, and the R Studio is the dashboard. Okay, so all the program or the command that you write in the R Studio, okay, these are supported by or executed by the R programming, okay, which runs in the background. Okay, and then it is visualized in the dashboard. Okay, so this is the structure of the R and R Studio. Okay, now the R Studio has 4 panels in its layout. Okay, layout of R Studio. Okay, so it has 4 panels. Okay, the number one editor, the number one is source editor. Okay, it is the place or pen where you write scripts. Okay, number 2 panel is the console. Okay, I will show it to you in the R Studio also. Okay, the second one is console. Okay, console is where the program runs actually. Okay, the third panel is the environment or history. Okay, in this panel, okay, it shows past commands and different variables. Okay, and the fourth one is the packages or files plots. Okay, we can say the package span or file span, or we can say the plots span. Okay, now as the name suggests, okay, this is for the where we visualize. Okay, we can see the files and plots, etc. Okay, so these are the four panels of the RStudio. Okay, let me show you these panels in the RStudio. Okay, now we have these 4 panes: 1, 2, 3 and 4. Okay, this is where we write the script or the program. Okay, here this is the console. Okay, here the program will run. Here it will show the history. Okay, all the history will be here, the past commands, etc., all will be stored over here. And here we have all the plots. If we want to plot something, the plot will be visualized over here. Okay, we can see the files over here, just like we have these files. Okay, so this is the overall layout of the RStudio. Okay, in the next file I will be starting with the syntax of the R. Okay, in this video we will be doing the basic syntax of R. Okay, and we will learn how to write a program or a command in the R language. Okay, so the very first thing, okay, is the comment. Okay, comment is anything, okay, that you want the R program not to read or act on it. Okay, for example, you want to post a comment, okay, on in your program, okay, for someone, okay, like for a developer or for a reader, okay, but you want that comment to not be read by the R. So what you do for the comments, you put hash. You start with hash. When this line is started with hash, okay, then it becomes a comment. Okay, so putting hash and then writing, for example, program for addition of 2 variables. Okay, now this line, okay, now for this line will be, it will be visible in the R language, in the RStudio, but it will not be read by the computer. Okay, they will not act upon it, and it will be visible for the reader or the developer. Okay, and computer will be ignoring it. They will not act upon it. Okay, let me show it to you in the RStudio environment. Okay, now here we can write the script in which we have 1 2 3, the numerical lines. Okay, now if I write hash, if I start with hash, okay, I started with the hash. Okay, now the computer understands that it is a comment that is being made by the developer or the programmer. So the computer will not act on it. The computer will ignore it. For example, I write it, this is an experimental program to add two variables. Okay, you see, nothing happened. Okay, and the environment is empty because this is not a command. Actually, the computer has not acted upon it. This is called comment. Okay, now we will go back and we will have another function or command. This is the first thing. Okay, now the second thing in the syntax section is that R is case sensitive. Okay, by case sensitive we mean that if I assign a value, okay, to small x, okay, for example 10, and we have a capital X, okay, so the R language will understand that this X is different and this X is different. It will not take it equal. Okay, so this is the nature of the R language, that it is case sensitive. So if we put two variables, okay, two alphabets, and both are case sensitive, one is small and the other is in capitals, okay, so it will act as two different variables. It will keep it as two different variables. Okay, they will not overlap in the R language. Okay, number third is the assignment operator. How to assign value to something. Okay, assignment operator. This is assignment operator. Okay, we have two kinds of assignment operator. One is this and one is equal to. Both can be used as assignment operator. Okay, for example, I assign x a value of 25 and y a value of 35, and I want to add it. Okay, so I can assign using these symbols, or I can have x is equal to 25 and y is equal to 35. Both are okay, but we will use this sign mostly. Okay, how can we actually insert it in the RStudio environment? Okay, so we can insert this sign in the RStudio environment by using the keys, which is alternate and adding the negative sign. Okay, these two keys, alternate plus negative, so it will automatically insert this sign, the assignment operator. Okay, and assignment operator is used to assign value to any variable. Okay, so let me show you the case sensitiveness and the assignment operator in this video tutorial. Okay, so in the second line we will be adding or assigning values to two different variables. Okay, now for example, I take small x, okay, and I assign it a value of 15, okay, and press enter, and then I take capital X and I assign the value of 25. Okay, now the system will understand that this small x is some other variable and the capital X is some other variable. They are never equal in the R studio or in the R language scenario. Okay, maybe in most of the programming these are equal, but in R they take it at different variables. Okay, now to have the assignment, okay, now I will make a small program, okay, by adding two different variables. Okay, so let me add in the fourth line, let me add a variable x, for example a variable y, for example. Okay, so y, and I press Alt plus the negative, okay, and it will automatically show the assignment operator. Okay, now for example y is equal to 35 and I press enter, okay, and z is equal to 25, okay, and now I want to add y and z. Okay, so I say y plus z, okay, and then I select these and I press run. Okay, now why I selected these? Because I want to limit my program from the fourth line up till the sixth line. Okay, I want to execute only these three lines. Okay, so that is why I selected these three lines, press the run button, okay, and here are my results. The answer is 60. Whenever this one comes, this one means result. Okay, and here in this environment we have the program values for y is 35 and z is 25. Okay, this is my lines. This will transform here. Okay, and if I save it, it will be going here, it will be shown here. Okay, and if I want to visualize any of this, because we will be plotting inshallah in the next videos, we will be going to plotting some things like box plot and histogram, making histogram, etc. So that will be shown over here. Okay, so this is how you execute a program in the RStudio environment. Okay, so what you do, you select those lines which are your intentions, which are your concerns, and then go to this run button. Okay, when you press run, it will be executed over here, the result will be shown here, and the program will be, the commands, those will be added over here, they will be listed over here. Okay, so I can have the history over here. Okay, this is my history. The history shows that I assigned y 35 value, z 25 value, and then I executed y plus z. Okay, so this was one of the small examples, okay, based on the three basic syntax that we just did. Okay, now we will moving forwards to the data types and all these functions, and then functions and so on. Okay, so in this section now we will move forward in the syntax section. Okay, so we have sign of interrogation over here, okay, as the next command or syntax operator. Okay, now what does the sign of interrogation means in the R language? Okay, so the basic function of sign of interrogation is to open documentation for the related function, okay, when sign of interrogation is used before it. Like, I want to find the mean of something, okay, but I don't know how to find mean in our language. So what I will do is, I can do it in two ways, okay. There are two ways to do it. The first way is to start with sign of interrogation and then write mean and press enter, okay. So what it will do is, it will invoke the R language, and it will show you in the directory that how you can find the mean, okay. The second thing is to write help, okay, and in the bracket you write mean. If you execute this command, it will also do the same thing, okay. Let me show it to you in the RStudio environment. Okay, now we are back into the RStudio environment. So what I write is, I write sign of interrogation and I write mean, okay. Now when I run it, you see here is all the explanation of this function, okay. Now here is the arithmetic mean, the generic function of the term arithmetic mean, usage, mean, x value this, and you can have all these like this. So it will show you the exact way how to do it, okay. Now I will do the other method, okay. Now the second method to do is to write help and write mean, and when I execute it or run it, it will show me the exact result that it show me with the sign of interrogation and mean, okay. One other thing is that in our language, okay, it doesn't start with the number, okay. The line or the code that you write, it never starts with a number, okay, and it does not have any of the special characteristics, okay. Remember these kind of things, okay. So this is how we can take the help of the RStudio, okay. If you do not know how exactly to take a function or make a function work, okay, you just write help and in the bracket you write the function name, okay, and it will tell you how to write it exactly. It will show you the exact syntax in this fourth window, okay. Okay, one other thing, that for example you start the line with the double sign of interrogation, okay, so it has a specific meaning in itself, okay. For example, I want to find about the regression in R, okay. This is a topic, okay, this is not a function, okay, it is a topic, okay. Now this, if I run it, it will show me the regression, how to do it in R and all the related functions to regression over here, okay. This is showing all the the related things related to regression. This ANOVA, linear model fits, ANOVA tables, fit and analysis, variance model, all of the things regarding regression, okay. Now here we have the regression, this thing, okay. So you can pick any of this, okay, and find the things that you need, Okay, this is predict method for linear model fits, profiling GLM objects, and so on and so on. You will have all the details regarding the regression, all the things. Okay, so the double sign of interrogation, it will trigger the R Studio to list all of the results, okay, that are related to your question mark that you mentioned. Okay, like I mentioned regression over here, so it has shown me all the things that are related to regression. Okay, so you can have all these things, read about it, pick the functions from those tables, and you can apply it over here. Okay, so this is how the double sign of interrogation works. Okay, now we will move forward towards the data types. Okay, there are always some functions, or we can say reserved variables that are already set in the R language. Okay, you can change that, but it will make the problems complex. For example, if I write capital T over here, okay, so this is one of the variable, okay, that is already fixed in the R language. Okay, so if I execute it or run it, okay, it will show me this result 1 true. Okay, it means that this capital T is reserved for the true in R language. So you cannot have a variable capital T, okay, because it is already reserved for true. Okay, so whenever we take capital T, it is reserved for true. However, we can add a value to capital T, but it will complicate the things. So try not to have these kind of variables being used by your code. Okay, let me show you some of the variables that are already reserved in the R language. Okay, so these are the symbols: small q, small t, capital I, capital T, and capital F. These are the symbols that are already used by the R language. Okay, so try not to assign any values to these. Okay, because capital F is for false, capital T is for true. Okay, I don't know what is I for. We can search over here. Let me search it. Okay, so if I press capital I, okay, and then run it, okay, so you see this is already reserved class X. Okay, if I say small q, okay, let me run it. This is reserved for this function. Okay, save function. Okay, so you see we have some functions that has already been allocated, so don't use those functions, okay, because they are solely for the R language. Okay, but we can use it. Actually we can use it, but if you assign any value to it, it will make the things complicated for the R language. Okay, so the result may vary because of these, so we should avoid using these kind of variables. Okay, now getting towards the data types. Okay, so there are mainly 4 kinds of data that can be used in the R language. Okay, the very first kind of data is numerical. Okay, the second one is integers. The third is character or text, and the fourth one is the logical. Okay, so these are the four kind of data that can be used. Okay, by numerical we mean that 1.1, 3.4, 4.0, 59.6 and so on. So this is the numerical form of the data. Now by integer we mean 1, 3, 5 and so on. Okay, and other we have text or character, like we want to print something. Okay, like I say in the what we say there, hello, in the this is the exact text that you want to print or something. Okay, so this is done like this. Okay, so we have text or character also in the data types, and the fourth one is the logical, like true, false, etc. Okay, so all of these data types are here in the R language. Okay, for example, I want to have name, okay, and I assign it Ali, for example. Okay, now this text, okay, this is saved in this variable. Okay, for example, score, and I assign the value 95. So this 95 will be saved in the score variable. Okay, and passed, and I say true. Okay, so this is the logical, and it will be saved in this one. Okay, so we can have all these data types in the R language. Okay, now we are moving towards the data structures. Okay, like vectors, matrices, matrix, vectors, list, etc. Okay, and then we will go towards the operators. Okay, and in the end we will be doing the functions before we go into the complete solved examples, like in what the professor did in the in the class. Okay, which has a big equation that is followed throughout the problem solving. Okay, we will also go towards the plotting and all these, but let's just first do the what we say, the data structure. Okay, so now we will be studying some of other operators that are commonly used. Okay, so what we have done up till now is, like, we comment, which is like done with this sign hash. Okay, assignment operator, which is done with this. Okay, multiplication, it is done with asterisk. Okay, like A asterisk B. Okay, other than that we have exponentiation. It is done with this sign, like 2 raised to the power 1.5. Okay, we write it like this in the R language. Okay, now the other one is sequence. Okay, so sequence operator. Okay, this is this colon. Okay, colon sign is operator like we say 1 colon 6. Okay, so it will sequence it in 1 2 3 4 5 6 like this. Okay, I will do it in the R language also, but I am just showing it over here so that then I can explain one by one in the R language. Okay, and we have another one, special sequence from A to B by H. Okay, so we write it the same sequence or sequence A comma B comma H. Okay, like for example we want to sequence from 1 to 7. Okay, and with a difference of 0.5. Okay, so if I write like this in the program, so it will sequence it like 1 1.5 2 2.5 3 3.5 and so on up to 7. So the difference will be 0.5 in each of the number because we have divided by H, and it will sequence it from 1 to 7. Okay, so this is for special sequence. Okay, and we have concatenation operator. Okay, concatenation operator. Okay, defined by C, and we write it like C bracket 1 2 3 etc. Okay, so it gathers numbers into a vector. Okay, this is the concatenation operator. Now I will do few of the operators in the R language. I will do the multiplication as the exponentiation, sequence and concatenation. Okay, so let's do it in the R language. Okay, so this is our main window. Okay, now if I want to multiply two variables, okay, so I can also do it directly like 5 asterisk 3. Okay, I can also do it like this and run it. Okay, and here we get the results. Okay, here we get the results. Okay, I can also do it like this. Other than that, I can have I can use the assignment operator. Okay, so for the assignment operator, what I will do is I will say A alt plus subtraction sign, so it will assign some value to A. So let's suppose A is equal to 5. Okay, and B alt plus okay, now we have given values to A and B. Now if I want to find A cross B, then it can, so I will have to select those lines which I want to execute. Okay, and press run, so it will give me the same results. Okay, now I will show you the sequence one. Okay, now if I want to sequence, okay, and I start the bracket. Okay, Now it wants me to write 3 things in here. Okay, from where you want to start. For example, I want to start this sequence from 1, okay, then comma, and then the ending of it. Okay, so for example, I want to end it on 15, okay, and comma, and how much should be the difference between two consecutive sequence numbers. Okay, for example, I want to have the difference equal to 3. Okay, now if I select this and run it, so it will give me a sequence. Okay, it has given me a sequence of 1, 4, 7, 10 and 13. This is the sequence that is given to me. Okay, for example, I want to have the difference of 0.5 in between. Okay, so now it will give me sequence from 1 to 15, but it will give me the difference between two consecutive numbers as 0.5. So it will start from 1, go to 1.5, 2, 2.5, 3, 3.5 and so on up to 15. So let me run it. Okay, when I run it, you see this has given me the exact sequence that I was talking about. See this thing. Okay, 1, 1.5, 2, 2.5, 3, 3.5. The difference is 0.5 because the third number h is 0.5. Okay, A, B and H. Okay, now if I want to sequence it, make a sequence by using the second method, simple sequence. Okay, so I can just use the colon. Okay, so 1 colon 6. Okay, and let me run it. So it will be give me a sequence of 1, 2, 3, 4, 5 and 6. Okay, so this is another way, but this is very defined way, like how much difference do you want between the two numbers, and this is in general, like the difference will be same, like 1 to 2 the distance is 1, 2 to 3 the distance is 1, up to 6. Okay, so I have copied these two. Okay, now I want to make the exponent of a cross b by some number. Okay, so let me put it this. I will copy it over here. Okay, now I put it into brackets, and then after bracket I say raised to the power and I say 5. Okay, now let me execute it. Okay, so now what it has done is it has multiplied a cross b, and then the result of a cross b, it has taken the power of 5. So the answer is 759375. Okay, so that is how you take the exponent of something. Okay, now one operator remains, which is the concatenation. Okay, so let me do that also. I hope you are understanding the basics of it. Okay, once we understand the basics of it, then we will do the problems that were given by the professor, and we can explain it well, and we will understand that problem once we are done with these kind of things. Okay, now doing the concatenation, so let's suppose I have assigned nums, okay, to this concatenation. Okay, and in this concatenation I am putting the values like an array of numbers like 3, 5, 7 and 9. Okay, now when I execute it, it will show me an array of numbers. Okay, let's suppose I write nums over here. Okay, now I have defined nums over here, So when I run it, so it will give me, sorry, I have written nums over here. Okay, so as already nums is defined in the line number 22 as a concatenation an array of numbers 3 5 7 9, so here it will give me the same result 3 5 7 9 as nums. Okay, beside numbers, okay, we can have characters also. Okay, for example, I take x and assign it, okay, concatenation of, for example, Ali and, for example, Anwar we must put the characters in the, I don't know what it's called. Okay, so now we have done it. Okay, now when I press enter and I say X, okay, and I execute this, object X not found. And let me show you why it is saying that object X is not found. This one, okay, because we have already one X over here. Okay, so let me reintroduce it as not X but something like G. Okay, now when I execute it, so it will give me Ali and Anwar. Okay, similarly we can have a combination of numbers and characters and logics, everything we can, link any of these things, whether it is a number, whether it is an array of characters, or whether it is a combination of characters and numbers. We can have anything, we can use anything for this concatenation C. Okay, so now we will go to the next topic, which is the vectors. Okay, we will discuss some vectors and functions, and after that we will go towards the problem. Okay, so some commonly used functions. Okay, so the very first one is square root. Okay, how do we take square root in the R? So for square root we use sqrt as the function. Okay, now for natural log, okay, we take just log. Okay, for exponential function, we just keep exp. Okay, for taking the factorials, we say factorial. Okay, now if you want to define random uniform numbers, for random uniform numbers we say RUNIF. Okay, this is the function. Okay, now for random normal numbers, we say R norm. R random uniform, R norm means random normal. Okay, for normal distribution, okay, we say the P norm, okay, T norm and Q norm. Okay, these are all the functions that we use for normal distribution. Okay, to rank and sort numbers, we say rank and sort, just like it. Okay, we do all these in small. Okay, not a single one is in the capitals. Okay, and for variance and covariance, to find variance and covariance, what we do is we say VAR for variance and COV for covariance. Okay, for standard deviation and correlation, we say SD for standard deviation and correlation COR. Okay, for frequency tabulation, frequency table, we say just table. We write table and it will form the frequency table. For any missing values, we say capital NA. Okay, or S dot NA. Both of these are okay. Okay, so these are all the functions that are commonly used in the R. Okay, now we come to vectors and matrices. Okay, so let me write some functions for vectors and matrices. Okay, these were common functions. Now these are functions for vectors and matrices. Okay, functions for vectors and matrices. Okay, now if you want to define zero vector, what we do? Okay, for zero vector, we have a symbol numeric n. Okay, like for example, x assigned value of numeric n. Okay, so this will define the zero vector. Okay, or integer n is also rep 0 n. This is also a zero vector. Okay, now to define zero matrix, okay, so we have matrix 0 n and m. N and m is order of it, and 0 is, it means that every single one number is 0 over here. Okay, so for example, you want to define matrix x. Okay, what we do is we assign this matrix to x. Okay, and we say matrix 0 n and m. We can say n and m like 1 cross 3 or 2 cross 3. We can assign any value to n and m. Okay, we can say 2 cross 2, so n is equal to 2, m is also equal to 2. Okay, I will do it in the R language also. Okay, now when we say the ith element of a vector, okay, ith element of matrix or vector, Okay, so we say A and square bracket I. Okay, for example, the ith element of matrix A or vector A is assigned value of 0. It is 0. So this is an example of it. Okay, we can write it like this in the R module. Okay, now if you want to define the jth column of matrix A, jth column of matrix A, so we can say capital A square bracket and J. Okay, for example, sum of the jth, so it will sum all the jth columns. Okay, similarly we can multiply, we can have transpose of it, inverse and diagonal, all of these. Okay, I will send you a list of it. Okay, so these are all the functions for vectors and matrices and commonly used functions. Okay, so now let's do some practical examples on R programming or R coding. Okay, so the first example, so we will start with something that is of some mediocre level and we will go towards the complex problems. Okay, so that we can understand step by step the complexity. Okay, so the first example that we will do over here is that we need to define an R function that sums or adds the roles of n number of fair dices, okay, and return the sum. Okay, not only just sum it but return the sum value. Okay, now to explain the question, okay, it means in simple layman terms, it means that we have a dice. Okay, we have n number of dices. Okay, Ludo. Okay, now those n dices, okay, those n dices are rolled. Okay, so a dice can have a value from 1 to 6. Okay, any of the random value. Okay, if I roll a dice, so it can return the value of 1, 2, 3, 4, 5 or 6 randomly. Okay, so if we roll n number of dices, so it will roll n number of values and these values are random from 1 to 6. So the problem here is that we have to roll n number of dices, sum the values for each of the dice, okay, and then return that sum on our screen. What is the sum? Okay, now the very first thing in coding that we will do is to code it. So the first line of code that we will write in R, it should be about the function. Okay, we will make a function of the sum dice. Okay, then we will assign some values to the roles, to each role. Okay, so each role can have a value of from 1 to 6 and there are n number of dices, and we will do that, and then after that we will have a third line in which we will return the sum of those roles. Okay, so let's write the first line. Okay, so the first line should be sum dice, okay, and we assign the value to some dice as function of n, and we will have this bracket, the curly bracket, okay. So we have a variable some dice assigned the value of function n, and this braces starts. Now this braces start because the next line that we will be writing, okay, it will all be contained in this body of this function. So that is why we start this braces, and in the end we will close the braces, okay, so that the lines that we write are exactly in the body function, okay. Now after some dice, okay, we will have the next thing that we will do is to define the roles, okay. By roles I mean ROLL role, okay, rolling a die, okay. So we will define each role for n number of dices, okay. So we know that each role can give us a value of 1 to 6 randomly, okay. So we have to sequence that, okay. The size of the sample size is n, and we will have a condition that the replacement is true. It means that many of the dices can give us a value of 1 or 2 at the same time, so the values are replaceable, okay. So this is a new variable, okay. Roles, we define roles, and in the roles we can have you want to have like sample of 1 through 6. So these are the values at random, okay, that each role can have, and the size is equal to n, and replace is true, okay. Now we have to sum these roles, okay. So to return the values, okay, so we can have some roles, okay, and then the braces is closed. So these lines are in the body of this function, okay. Now let me type this in the R function to have all these values. So now let's do the programming, okay. Now the first variable that I will be introducing is some dice, okay, and using alt plus negative we are assigning this a value which is function n. Function, if I double click on it, so you know it is taking the function from the library, okay, and we start the braces, okay, and press in the middle of these braces I press enter, so the braces start and the other one ends on 28 over here, okay. Now it will allow, and then the braces is closed. So these lines are in the body of this function, okay. Now let me type this in the R function to have all these values. So now let's do the programming, okay. Now the first variable that I will be introducing is some dice, okay, and using alt plus negative we are assigning this a value which is function n. Function, if I double click on it, So it is taking the function from the library, okay, and we start the braces, okay, and press in the middle of these braces. I press enter, so the braces start and the other one ends on 28 over here, okay. Now it will allow me to write the body of the function in between these braces, okay. Now in the body of the function, okay, we have to define the roles, okay, we have to define the roles. So let me introduce another variable, which is roles, alt plus negative. So roles is, we have a sample, okay. If I double click on it, it will give me the exact syntax of it, okay. We have to define x, okay, what is the value of the sample, the size of it, and replacement if false and if there is any probability, okay. So the very first thing is x. So the value of this sample of a single die, okay, it should be between 1 and 6 randomly. So what I will do is I will write 1 colon 6. So it will be from 1 to 6 randomly, and then comma, okay. So x is defined. Now the size, for size I will write size is equal to, we have the sample size of n, so n is the sample size, and then comma, and I will say then replace is equal to, and I will say true, okay. So each role has a sample size of n, okay, n dice, n number of dice rolled, okay, and each will have a value from 1 to 6 randomly, and replacement is true. It means that the dice will have, any 2 dice or more than 2 dice can have a value of 1, okay. It can have a value of 2, it can have a value of 3, or a value of 4, okay. So that is why we say replacement true, okay. Now when I press enter, I will come to the next line. So in the next line I have to sum these roles, okay, and return the value. So I will say the return function, so double click on it, so it will give me the exact syntax of it. So I want to sum the roles over here, so sum, and I will say roles, okay. Now our program is, code is ready, okay, but it will sum the roles and return the value, but it will not show the value over here, okay. So if I say run, so it will run the program correctly, but it will not show me the value. To show the value for n number of roles, I have to define this n, okay. If I define this n like n number, for example 10 number of dices, okay, if I define this n as 10, then it will return the value over here, okay. So for that I need to write another line, okay. What I will write is, I will write sum dice as a function of n, okay. So sum dice, this is our ultimate function, okay. This is the function n, okay, and this function n is stored in the sum dice. So to return any value on the screen, I have to pick some dice, okay, some dice, and for example I say roll 100 dice, okay. Now if I run this, it will return me the value, which is 334. So if I roll 100 dice, randomly, So the total number of values of their appearance, like 1 to 6, it will give me a sum of 334 randomly. Okay, I can have it for the 50 dices, 100 dices, 1000 dices, and so on. So it will give me the value. I hope you have understood all these things. Okay, thank you. This was one just simple example. Okay, now we will move towards the what we say, the complex problems.